What we're looking at today is addition, subtraction, and multiplication. Yes.
Yesterday, I think I tried to put it in my bag, but I think I missed my pocket. I tried to put it on this pocket right here, but I guess I missed it.
Oh, yeah, I'll trade you. I mean, I got my foot in this.
All right, guys. So what we're looking at today is addition, subtraction, and multiplication. So far, we've actually covered addition, subtraction, and multiplication. We've covered all three. Because we covered multiplication yesterday, and we did addition, subtraction last week. So what we're really looking at is just a different way to denote it. So here, find f plus g of x. So when we have it written out like this here, f plus g of x, that's actually how, well, we pronounce it. It's f plus g of x. Of x. And what it's really looking at is this here is the same thing as saying f of x plus g of x. It's just f of x plus g of x. It's just these two functions being added together. And this is just another way to write it. Now, our f of x is what? Squared. Mm-hmm. And since we're adding it, we really don't need to worry about our parentheses. We have this here. So really, it's almost the same as just saying f plus g of x is the same as saying f of x plus g of x. Well, f of x is 3x squared plus 5x minus 2. So we replace f of x with it. G of x is x squared minus 4x plus 6. So we replace g of x with it, because that's what they are equal, so we replace them with it. So any questions on this here thus far? Are we good with this here? Yes? Okay. So we'll start off with the biggest exponents first, the 3x squared. What's like terms with it? Mm-hmm. So I'll put it next to it so we know that those are like terms. We'll combine them here in a minute. 3x squared and x squared are like terms, yes? So we'll add them here in a minute. I'm just writing them next to each other first. Well, we have 5x. Is there any like terms with 5x? Well, then we have negative 2, and its like term is? Mm-hmm.
I didn't know anything at all.
The 3x squared.
Can you actually do that all over again? Like the bottom part?
Here. Go for it.
The 3x squared and the x squared are the exact same. Like they are the same because they have the same like x squared. You know what I mean? And then the 5x and the negative 4x are the same because they're not squared.
Right. So we could do this if you're able or kind of can keep track of the numbers in your head. We don't have to write this step out. But it's sometimes good to write this step out so we can kind of see what the like terms are and put them next to each other. Now what we want to do is we want to combine our like terms. So 3x squared plus x squared would be what?
That's why he grabbed it.
Well, 3x squared plus x squared is going to be what? Because how many x squareds do I have? I have 3 and, so I have a total of 4. Now in the middle I have 5x squared minus, or not 5x squared, 5x minus 4x. What would that leave me with? Mm-hmm.
Yeah, one.
Plus x, because 5 minus 4 is positive 1. Negative 2 plus 6 would be plus 4. So f plus g of x is 4x squared plus x plus 4.
Okay, so you are taking this formula right here, f plus g of x,
Yes.
and then you are finding out these two expressions up here.
What they are added together. So that's really what we're doing. We're just taking the functions f and g and adding them together. So really what we did previously we just started here and went down. Really, we're just adding some notation to it. That's it. That's all that we're really adding today. Now this next one here is f minus g of x. So what do we think this is the same as? So this here would be f of x what? G of x. So f minus g of x, we have f minus g in parentheses and then x, f minus g of x, is the same as f of x minus g of x. And the order will always go whatever letter goes first. Since f went first, f of x will go first. Since g came second, g of x will come second. That makes sense. Because if it was g minus f of x, it would be g of x minus f of x. They always go in order. Now, because we're talking about subtraction, I will use parentheses because, again, with our negative coming in with subtraction, it's going to change signs. Now, f of x in our case is 3x squared plus 5x minus 2 minus, well, g of x is x squared minus 4x plus 6. Any questions on this here thus far? Okay?
If it was
Plus g of x, there's a plus sign.
Mm-hmm. Yep. Yeah. F minus g of x is telling us that we're subtracting, where f plus g of x would be adding. So here, since it changes to f minus g, we're going to be using subtraction. So our f minus g of x would be the same as f of x minus g of x, which then we can just plug in the functions f of x and g of x, what they are. So any other questions on this here?
wait, so that's it?
Well, we have to actually subtract them, but yeah. Now, since we're subtracting, we're going to need to apply that negative in the middle to g of x, because it's in front of it, yes? Because this negative here is going to affect everything inside these parentheses here, the second set. Because really what it's saying is that it's being multiplied by negative 1, so everything in it will change signs. Now, is there anything in front of the first set of parentheses? No, so the signs will stay the same. So it would be 3x squared plus 5x minus 2. Now, what will we have with the second set? Yes? Yes, because the signs are all going to flip. Positive would become negative, and negative's positive, because we're multiplying it by a negative 1. Any questions? Okay. Now, it's kind of we've been doing, it's kind of good habit to do. Let's put the like terms next to each other. Now, 3x, or x squared is the biggest term, so we'll start off with 3x. Any like terms with 3x squared? Negative x squared, so I'll move it next to it. So, negative x squared. Hold on one second. Yes? Yeah, okay. I had thought you had a question.
Hey, wait, why is it plus 4x if it had a minus sign on it?
Because since we're subtracting, because really what we're saying here is that we are subtracting negative 4x. Because when we subtract a negative, it's the same as it becoming positive, because the negative and negative make a positive. And that negative gets applied to everything inside this set of parentheses here. Because when we subtract x squared, subtracting x squared is the same as negative x squared. When I subtract 6, it's the same as saying negative 6. Kind of see how that works there. Any questions on how we got to this here, or any of our signs? So if we can combine our like terms,
Would the first one be negative 2x? Or would it be 2x squared?
yes. Because I have 3 of them, and I'm taking 1 away. 3 minus 1 is 2, and it would be positive, because I have 3. Because 5x plus 4x? Yes.
So if it's negative 2, you take out 6.
Yes. If you owe me $2 and then you owe me 6 more, how much do you owe me?
8.
Mm-hmm. Yeah, negatives are weird. When we subtract a negative, when we're subtracting a negative, it would make a positive. When a negative multiplies by a negative, it makes a positive. When we subtract a number from a negative, it makes it a bigger negative.
I was just thinking
So taking away, we're still pulling away from it. So it's going to keep going down. It's a weird thing. It's weird how those, because it feels like it should work that way, but it doesn't. Yes. Any other questions on this here? How do we feel about this addition subtraction? Confused? Okay. I just didn't know if this was confusion or not. Okay. So we feel good with addition subtraction. We like it for the most part, better than stuff we've covered before. Because really this here isn't adding anything really new. I mean, we have new notation. We have a new way to write it, yes? But the operation and what we're doing hasn't changed from what we did last week. It's still just combining like terms, adding and combining like terms, yes? Do we want to see this one here? Would seeing this help you better understand it? Yes? No? Okay. Because what I want to look at is this one here also, our multiplication. F times G of X. F times G of X. What this is saying is that we have F of X and we're multiplying it by G of X. F times G. of x. So it's f of x times g of x. We're multiplying the two functions together. Okay. So what is f of x? X minus 4. Now g of x is 2x squared plus x minus 3. 2x squared plus x minus 3. Now we worked with multiplication some yesterday, and I'm realizing we didn't do any like this here, but that's not a big deal. Now before we go and multiply, are there any questions on how we got to this point here? So we're saying that they're multiplied together, we replace f and g of x and have them written as multiplication, yes? Now we worked with multiplication yesterday. We talked about FOIL, first, outer, inner, last, or really our distributive property. So with our first term, which would be x here, yes? Because yesterday we multiplied by everything in the other set of parentheses. And we only did it twice here. We're going to do x times 2x squared. We're also going to do x times x, and then we're going to do x times 3. So this time, instead of doing it twice like we did yesterday, we're going to do it 3 times. So we have x times 2x squared. So we have 2x squared. Let's just go on, we'll write it down. 2x squared times x would be our first one, because we're multiplying those together. And they're positive, so we wouldn't put a sign in front of it since it's first. Now we're going to have x times x. So I have plus x times x. And last we have x times negative 3, which would be negative 3 times x. So any questions on how we multiplied so far? So we just kind of written it out. Now what we're going to do next is we're going to do the same thing with negative 4. So we'll have negative 4 times 2x squared, because those two are going to be multiplied together. Now we're going to have negative 4 times x. And lastly, we're going to have negative 4 times negative 3. Well, we're going to multiply them. I just rewrote them out so we can see them, because we're going to multiply here in a second. So whenever we square something, we're saying that it's multiplied by itself, yes? So x squared is the same as x times x. Well, x squared times x is going to be x cubed, because we have 2 of them, and I multiply it one more time. So how many times is it being multiplied by itself? 3. So it's x to the 3rd, because it's multiplied by itself 3 times. Questions on that there? Yes, sir?
How did you get that many x's? Like,
Mm-hmm.
If you multiply x that, and then you multiply negative 4.
all the way across? Because x times x squared gave us 2x squared times x. Negative 3. So that gave us these first three. Now, when we did it with negative 4, we got these other set. Now, if you're thinking about the ones we did yesterday, we had 2 terms and 2 terms at most. So it gave us less, because now we have 2 and 3. So it's going to be bigger. Does that kind of make sense? Plus, well, x times x would be squared, because x times x will be x squared. Now, the next one here, negative 3 times x, is, well, negative 3x. Any questions on these first three? Now, the next one here, negative 4 times 2x squared. Well, I can do negative 4 times 2, yes? It's going to be negative, and 4 times 2 is x squared. Since we didn't do anything with the x squared term, it just stays x squared. We haven't multiplied it by an x. Now, the next one is negative 4 times x, which would be negative. And last but not least, we have negative 4 times negative 3, which would be plus 12. A negative times a negative is a positive, and 4 times 3 is 12. Any questions on this here before we start combining like terms? Now, it might be a little bit easier to have the like terms next to each other. So I'll start out with 2x cubed, because x cubed is the variable with the biggest exponent, yes? And if we're going to have it in standard form, it has to go first. Are there any like terms with x cubed? So for it to be like terms, it has to have an x to the third. Are there any others with x to the third? No, it's by itself, isn't it? Because it's the only term with x cubed. So it is by itself. Now, positive x squared's like term would be negative 8x squared, because both of those terms have an x squared. They're like terms. So we've taken care of 2x cubed, x squared, and negative 8x squared. What term would go next? Yes. Any questions on any of this here? Okay, let's go on and combine our like terms. Well, 2x cubed is by itself, so it stays the same. Now, x squared minus 8x squared, so 1 minus 8. Seven x squared, because we have one of them and we're taking 8 away. 1 minus 8 would give us negative 7. Now the next set of like terms we have is negative 3x minus 4x. Negative 3 minus 4 would give us plus 12. And we get this here. Any questions on any of this here so far? We're good with this here? Yes? Okay.